Alright, hello everybody, and today I'm going to be having a look at how we can define Suvet equations on our CAS and how we can use them efficiently. So I have on the left here our 5 Suvet equations that I've listed out right here, and you'll notice right next to each one I have a variable listed out, so SUVANT. And if you have a close look at these equations, those are actually the variables that are not included in each of these equations. So all these equations right here does not include one of the Suvat variables. And this is actually how we're going to be able to identify which Suvat equations we're using based on which variable it doesn't have. So if we're trying to use the Suvat equation without the u, for example, we're looking at the second equation right here. So that's just our way of identifying which equation we use, and that's going to be very useful later on. So how exactly can we kind of put all of this stuff onto our CAS right here? Well, I guess the best way to kind of demonstrate this is just to walk through a very quick example. So we have a very fine gentleman, Mr. Mott, right here, linked to his YouTube channel in the description below, or you can click right here. He makes excellent CAS videos, so you should go check him out. So Mr. Mott is very late to class after just waking up from a nap in his office, which is 60 meters away from the classroom. So he jumps up and starts sprinting. So if he takes 10 seconds to reach the classroom, we want to calculate his acceleration, assuming it's constant. So how exactly do we go about approaching this question right here? Well, the way I like to do it is, first of all, I like to list out all the variables, also all the Suvat variables we have. This way we can identify which variables we know and which ones we don't know. So we have our Suvat listed out right here, and we can start filling in all the necessary information. So first of all, we know that his office is 60 meters away from the classroom. So we know that our displacement, our S, will be exactly 60. So our U, well, we know, he just woke up from his nap from his office, so we can assume his initial velocity is 0. And as for V, our final velocity, there's no mention of that in this question, so let's just leave it blank for now. And the acceleration, well, the acceleration is actually the thing we're trying to work out. And notice here, his acceleration is constant. And just a quick note right here, if we make the assumption that the acceleration is constant, then we can use our Suvat equations right here, because these equations work for constant acceleration. So our acceleration, as I said before, is this thing we're trying to work out. So I'm just going to put a question mark there. And for our t, well, we know he takes 10 seconds to reach classroom, so we know our t is 10. So this is all the information we know about this scenario right here. And notice that there's one variable that we kind of haven't filled in yet, that's our v. And this is actually a very useful thing to know, because we can identify which one of these Suvat equations is the most appropriate to work out the acceleration in this scenario. So we know that we don't care about RV, so we don't care about this thing right here. So that's why we're going to be picking the Suvat equation without the v. So we're going to be picking this third Suvat equation right here. So that's why knowing which one of these variables that's not included in each of these equations is a very useful thing. Because usually with these Suvat scenarios, there's always going to be one variable that we don't care about. So just to make things a bit easier for us, I'm going to completely remove that v. Okay, and as I said before, we're using the third equation right here, so S equals ut plus half at squared. And then what we do from there, just substitute in everything. And then we're leaving the a as it is, because remember the a, our acceleration, is the thing we're trying to solve for. So just simplifying things and solving for a, we get a equals 1.2 meters per second squared. So you see this process here, we can kind of break it up into 3 distinct steps. We have, first of all, choosing the appropriate equation to use from our list of Suvat equations. Then we have step 2, which is inputting our variables, so this step right here. And then step 3 is just evaluating. So we want to somewhat automate this kind of process on our CAS right here, because if we can do that, then we can solve these scenarios in a matter of seconds, which is really nice in, say, an exam situation or something like that. So jumping onto our CAS right here, if we open up a new document and we go to our calculator page, we can start defining some functions that can help us solve these scenarios right here. So given that we have 5 Suvat equations right here, we want 5 functions we want to define. And each of those functions, we want to be able to input the necessary variables And then all we need to do is click enter to evaluate our missing variable. So in this situation, it will be an A, and I'll show you how to do that in the CAS. So if we go into a new calculator page, and we start defining some functions, I'm going to define a new public library function. So define libpub. That's going to make sure it's going to save it in our public library. So define libpub, and I'm going to call my first suvat equation suvat underscore v. So the reason why I put this underscore v right here, that's just to identify which one of the suvat equations from our list here we're going to be dealing with. So we're going to have suvat s, suvat u, suvat v, suvat a, suvat t, and those corresponds to the different equations we're going to be using. So it defines libpub suvat v, and what exactly are my variables? Well, we have our 5 variables, s, u, v, a, t, but remember with suvat v, this third equation right here, we don't care about the v. So what I'm going to do, we actually don't need to input in our v variable because, well, we don't really care about that. So we have this kind of input right here, but you got to consider another thing, namely that we're solving for one of the 4 variables in here. And the idea to kind of go around that on our CAS without defining like 4 different functions for each one is just by simply using the solve command. And the idea is we're going to be inputting a dummy variable into the variable that we're trying to solve for. So what do I mean by that? We're going to be using the solve command for that. So we're going to solve, and what I'm going to do is I'm going to input in this equation right here. So I'll just copy that over, and I'm just going to make sure I put multiplication signs right here just to make sure it's not treating as a single variable. So s equals ut plus a half at squared, and we want to solve it for a dummy variable, and that dummy variable I'm going to choose x. So whichever variable we're trying to solve for in this suvat right here, we're just going to replace it with an x. In this case it was an a. So we've defined our function, and all we need to do is click enter, and if we go to our var right here, we can see our function, our suvat v. So if we click on it, we can start inputting our variables. So notice at the very start I've listed out all my variables, s, u, v, which I've deleted a and t, and the reason for doing so is just to make sure that in our CAS right here, it's easier for us to know which order to input our variables. So we're just going to be inputting them in this exact order. So we're going to have 60, 0, then our a, and then our 10. So if we put this into our suvat, we're going to have 60, 0, and then the a, our acceleration, is the thing we're trying to solve for, so I'm going to put an x there, and then I'm going to put a 10, and if we enter, get an answer of 6/5, which if we approximate it is 1.2, and that's the exact answer we're expecting. So as you can see, we've kind of automated this whole entire process on our CAS, because notice we only needed to do 3 steps. We have choosing the appropriate equation. So when we define all of our suvats, we're going to have a list of suvats right here. Step 1, choosing the appropriate suvat equation, which we have, then inputting our necessary variables, like so, and then evaluating just by hitting enter, and our CAS will give us the value we're trying to solve for. So that's basically the whole idea. And if you want to do this on your own and define it for the rest of the suvats, make sure you save this document in the mylib folder. So if you want to save this thing right here, make sure it's under the mylib folder like so. And then what you can do is go to doc right here, and then refresh your libraries to make sure that all these functions you've defined are saved in your public library. But the nice thing is I've already pre-made a separate document just for that. So if I open up a new document right here, there it is. That's my suvat document that I've already made for us. So as you can see, I've defined all the suvats that we need. So suvat s, suvat u, suvat v, suvat a, suvat t. So those are all these equations right here that I've predefined them. Because let's switch over to handheld view. So let's actually just refresh the libraries just to make sure all these are saved. So now that we have all of these defined right here, let's actually have a look at another scenario. So we have a new scenario right here. We have a car which is traveling on a velocity of 72 kilometers an hour. The driver suddenly sees a fallen tree on the road 100 meters ahead and slams his foot on the brake. If the brakes can provide a maximum deceleration of 3 meters per second squared, will the driver stop in time before crashing into the tree? First of all, no matter what situation we're dealing with, we're going to list out our variables. So s, U, V, A, and T. Okay, and now I can start filling in the necessary information. So, a car is traveling at a velocity of 72 kilometers an hour. That implies that our initial velocity is 72 kilometers per hour. But make sure you don't leave it as just 72. Make sure you convert this value right here to meters per second, because those are the units we're using in these equations right here. We're using meters per second. So to convert kilometers per hour to meters per second, we just divide by 3.6. That's going to give us 20 if you plug it into your calculator. So what else do we need to know? We know that the driver suddenly sees a fallen tree 100 meters ahead. Let's actually leave that for now. Let's just read on. So we know the brakes can provide a maximum deceleration of 3 meters per second squared. So we know our acceleration will be 3, but make sure it's with a negative because we're decelerating. And the thing is, with the scenario, we want the driver to stop. So we want our final velocity to be 0. And what we actually want to do is we want to calculate the distance, because we want to know if the driver will stop within this 100 meters right here. So we want to figure out the distance so we can compare it to this 100 meters right here. So I guess this is all the information that we know. And notice that we don't have this t right here, so we can completely remove the t. And this is all the information that we're working with. So if we jump onto our CAS right here, we can go to our var, and then we can go to suvat. And remember, the t is the variable we don't care about. So we're going to go to suvat t. Then I'm going to input in all our variables. So first of all, we have s, which is the thing we're trying to find. So let's put an x there. Then we're going to plug in 20, then 0, and then a -3. And if we hit enter, we're going to get 200 over 3. If we approximate that, 66.67. And the nice thing is with this value is that 66.67 is less than 100 meters. So this means that the driver will stop in time before crashing into this tree trunk right here. So yep, that is pretty much it for this video. I hope you guys enjoyed it. I guess just a quick note, since we defined these in our public library and we save this file in the public library, what we can actually do is if we go to a new document, so new document, won't save that. If we add a new calculator and we go to this catalog button right here, you can see that we have our suvat. Well, first of all, if you go to this menu number 6 right here, you can see that we have our suvat drop down box right here. And from here, you can access all the suvats from any document. So if we have a new random document, we can still access all our suvats, and then it still works the same way. So yep, that is pretty much it for this video. I hope you guys enjoyed it. Link to the file will be in the description below, so you can download it for yourself and use it in an exam or whatever you want to. So yeah, I'll also have a instruction document down in the description below if you want to download that and check out how all this stuff works. If you don't have access to this CAS program, do feel free to come and see me, and I'll happily give you this program and download it onto your CAS. But yeah, until next time, have a wonderful day, and I'll see everyone later.